We want to talk about moles. Well, it's not exactly this one that lives mostly underground. We want to talk about the mole in chemistry. And a mole in chemistry, a mole of an element is the mass of that element in gram that contains as many atoms as there are in 12 grams of carbon 12. Well, but how many atoms are in 12 grams of carbon 12? In 12 grams of carbon 12 are 6.022 multiplied by 10 to the power of 23 atoms. And this number, 6.022 multiplied by 10 to the power of 23 atoms, is called Avogadro's number, and it is abbreviated, or the symbol for it is capital N and then subscript capital A. Now we can say a mole of an element is the mass of that element in gram that contains 6.022 multiplied by 10 to the power of 23 atoms. Where do you find the mole in gram for each element? You find the mole for each element in the periodic table of the elements. You see for sodium Na element with the atomic number 11, you find there a number that is 22990. And you will remember that this was the relative atomic mass number Ar. And we calculated that in the previous video. So if you want to know what the 1 mole of sodium is, just take the number 22.990 and write gram behind it. And this is 1 mole. So we can say 1 mole of an element is its relative atomic mass number Ar in gram. The unit for mole is mol, as we show here. This is mole. And 1 mole of X is equal to the relative atomic mass number Ar in gram. And this mass contains 6.022 multiplied by 10 to the power of 23 atoms, and 6.022 multiplied by 10 to the power of 23 is Avogadro's number. You can memorize this, but a scientist should know where this Avogadro's number comes from. So let us start out with the first definition. A mole of an element is the mass of that element in gram that contains as many atoms as there are in 12 grams of carbon 12. How many atoms are in 12 grams of carbon 12? The mass of 1 atom of C12 is 19.926 multiplied by 10 to the power of minus 27 kilogram. And if you convert that into gram, it is 19.926 multiplied by 10 to the power of minus 24 gram. And this is the way to convert kilogram into gram. Now calculate number of atoms in 12 gram of C12 that is equal to 12 divided by the mass of one atom of C12. So 12 gram divided by 19.926 multiplied by 10 to the power of minus 24 gram. And if you calculate it, you get equals to 6.022 multiplied by 10 to the power of 23. And this number is defined as Avogadro's number. So 12 grams of C12 contains 6.022 multiplied by 10 to the power of 23 atoms. This is Avogadro's number. And as we know, a mole of an element is the mass of that element in grams that contains 6.022 multiplied by 10 to the power of 23 atoms. Therefore, 12 grams of C12 is equal to 1 mole of C12. And the unit for mole, is MOL. Now you tell me, what is 1 mole of sodium-23, Na23? 1 mole of sodium, Na, is the mass of Na in gram that contains 6.022 multiplied by 10 to the power of 23 atoms of sodium. Now let us calculate 1 mole of Na in gram, of sodium in gram. The mass of 1 sodium-23 atom, that is essentially an atom that has 11 protons and 12 neutrons. This has a mass of 38.1754 multiplied by 10 to the power of minus 27 kilogram, and converting this in gram is 38.1754 multiplied by 10 to the power of minus 24 gram. The mass of that one atom we multiply by Avogadro's number Na, which is 6 multiplied by, which is 6.022 multiplied by 10 to the power of 23. And the result is 22.99 gram. So 1 mole of Na23, sodium 23, is equal to 22.99 gram. Where did you see this number 22.99 before? In the periodic table of the elements, 22.99 is listed as the relative weighted atomic mass, AR, for sodium, Na. Here, look into this periodic table of the elements, and in group 1A, period 3, Na sodium, above sodium you find 22.990, and then just add gram behind it, the unit gram, like this, and that gives you the 1 mole. And 1 mole of an element is its relative atomic mass number, AR, in gram. And you know that 1 mole contains 6.022 multiplied by 10 to the power of 23 atoms, and this number 6.022 multiplied by 10 to the power of 23 is Avogadro's number. What is the 1 mole of helium, it is 4.0026 gram. That would be 1 mole. What is the mole, 1 mole of krypton? It is 83.80 gram. So we say that this is true for every element on this earth. So let's just, but we want to prove this. Let's say you have AR gram of an element containing its isotopes in their natural occurrence, Na. Prove that this sample contains 6 multiplied by 6.022 multiplied by 10 to the power of 23 atoms. As we have learned in our previous video, the mass of one atom of element X is the weighted mass of its isotope, MWAV_X. For example, X is magnesium, Mg, and then please look at this table and you can see essentially on the right hand side how we have calculated the weighted average mass of magnesium using the weight of the mass of the isotopes weighted by the natural abundance. So the question we are asking is, if MWAV in gram is the average mass of one atom, how many atoms are in AR gram? So here you have the mass of one atom, that's the average mass, taking all the isotopes into account. And here you have the total mass of that sample, which is exactly AR gram. So now you have to calculate how many atoms are in AR gram. We do that in 3 steps. First step is MWAV in gram equals 1 atom. 1 gram equals 1 divided by MWAV atoms. And third, ARX gram equals ARX divided by MWAV atoms. Now we have to go back to our previous video. How did we calculate AR, the relative atomic mass? And the relative atomic mass is calculated by calculating the weighted average mass of the isotopes of an element and divide that by 1/12 of the mass of one carbon-12 atom. That is the definition of 1 U or 1 mu. So here we have shown that this is the abbreviation, and here we have it in kilogram, and as we used it before, and this is the mass of 1/12 of the carbon-12 atom. And we transform this into a gram, and then we have here in the numerator the mass, average weighted mass of the isotopes of element X divided by 1.660.5 multiplied by 10 to the power of minus 24 grams. Now take this circled expression, which is equals to AR. Take that circled expression and substitute that into equation 3. So this is now most important, because you see you have MWAVX in the numerator, and you have here MWAVX in the denominator, and they cancel each other out. So what remains is 1 divided by 1.605 multiplied by 10 to the power of minus 24. And please remember, 1.6605 multiplied by 10 to the power of minus 24 is the mass of a carbon-12 atom divided by 12 expressed in the unit gram. And by doing a few calculations, you get 6.022 multiplied by 10 to the power of 23 atoms. And this is the famous Avogadro's number Na equals 6.022 multiplied by 10 to the power of 23. And the unit that is used is mole to the power of minus 1, or per mole. Let me give you a simple example how to use moles. Table salt NaCl is created in this chemical reaction. Na plus Cl equals NaCl. How many grams of Na and of Cl do you need to assure that each Na atom has one Cl atom to react with? You need 1 mole Na plus 1 mole Cl, each mole containing 6.022 multiplied by 10 to the power of 23 atoms. Now look into the periodic table of the elements and find sodium Na, and look at the relative atomic mass Ar, which is 22.990. So you need 1 mole of sodium, which is 22.990 gram, and you need 1 mole of chlorine Cl, which is 35.453 gram. Sodium 1 mole, 22.99 gram. Chlorine 1 mole is equal to 35.453 gram, and each mole has 6.022 multiplied by 10 to the power of 23 atoms, which is Avogadro's number, and you have a perfect match. Every sodium atom has a good chance to find 1 chlorine atom. I hope this is not too hard for you, and we have to talk about this in more details.